Alright gang, this is video 12.2b. What I'm hoping is going to be a very short conclusion to section 12.2, highlighting binary fission to start here. And so this is what would happen in prokaryotes, just to kind of give an idea. They don't have a nucleus, they don't have centrioles, and their DNA, rather than being in the shape of an X like our DNA, like this, their DNA is a circular DNA, so it's one big circle. So we are showing in this diagram, they obviously are going to use different systems than us because they're so different. All right? And so they have a very, very simple, I think almost seems better, but a very simple way of splitting their DNA up. So they would have this set of DNA here would be one really large chromosome, and it's circular, and it's all jumbled around itself, okay? But basically, in the midst of it's being jumbled all around itself, at some point on that, there is a location. It's a sequence on the DNA, and that sequence is the origin of replication, they call it. But that is the spot where, when this thing replicates, that's where it'll start. Okay, and so they have it highlighted in green right here. As replication happens and we start to copy this DNA, we're going to end up with two copies in there, and we have to have some way to get them to opposite sides of the cells. They don't understand this 100% how it works, which I love it when science doesn't quite understand how things work. But anyway, they don't understand how it works, but they do think that somehow the origin of the two different copies of the genome, or the two different copies of the chromosome, that those origins attach to opposite sides of the cell. The reason they think this is because when the cell divides, so here the cell is kind of growing and dividing, the one copy of the DNA somehow gets dragged to the one side of the cell, the other copy somehow gets dragged to the other side, and they're not 100% sure how to explain it. So there's some evidence to suggest that there's actually proteins that connect the origin to opposite sides of the actual cell. So that's the binary fission. The reason I bring that up is we have not talked a ton about evolution so far in our course, and if you haven't picked it up as you're reading, every single section of the book comes back with an evolutionary piece saying, like, here's the significance of this for evolution, or here's why this is, or how this is backed up in the theory of evolution. So one of the questions that needs to be asked, if you're thinking through evolution, and scientists asked this question, they said, we've got, as we're learning about mitosis, well, mitosis are in eukaryotes, and then we look at this binary fission that we're seeing here, and that's in prokaryotes. And as we look on our evolutionary time frame, prokaryotes, these things are they've been around for so long, so much longer than the eukaryotes. So somehow this mechanism that we're showing here with the binary fission, somehow there was a change from this mechanism, it was a really long time ago, to the point where eukaryotes do something it's not even recognizably the same at all. So they had to come up with, like, how did this change happen? Otherwise, it's a pretty big jump to go from what we have here to what we see with eukaryotes with mitosis. Okay, so if we go to the next slide here.